Rec-
Then I'm going to also draw, oh, this is a rectangle. Maybe, I try to draw a perfect rectangle, still not looking perfect, right? So this needs to be extended a bit, and then I would get something like a rectangle here. So let's do one thing. We take segment once again, exactly do it here, then join this and this. So we took a segment and then we have drawn a rectangle here. Now I'm going to take a pencil and then explain something here. So this is your length. So maybe it's X. And then say this is your width, which is maybe Y. The concept is don't memorize something. If you memorize something, the chances of you forgetting is very high, right? So I started with very simple, and this is for very small children. It's not for adults. This class, who are getting exposed to geometry, maybe a third grade or a fourth grade student, and then he starts seeing the shapes. The first time the teacher tells, hey, this is the formula for a rectangle, and the area of the rectangle is simply the multiplication of the length of the rectangle, which is x, and the breadth of the rectangle. So say if this is maybe 6, right, centimeter, and then this is say 2 centimeter. So the area is nothing but 6 into 2, right? 6 to the 12. 6 into 2 equals 12 square centimeter, right? Now we need to realize that in order to be creative, in order for your logical thinking to come into play, you have to see the symmetry of geometry objects. So most of the times when the Greeks and Athens, they played with a lot of construction buildings and their creativity was getting triggered when they see the symmetric shape. So when I see a symmetry here, I will try to join this and this, right? So let me see if I can get a shape which is help me helps me to join this. So let's go back here, parabola, polygon, vector, line, segment. Let's take segment again. So I'm going to join this and this. Perfect. So now this became, I have exactly divided this rectangle into half. It looks like one triangle is sleeping on another triangle, right? Or one triangle is kept on another triangle in an inverted way. See the imagination. We can imagine a lot of things like this. So now I'm talking of only two dimension here. So now I'm interested in finding out, you know, what is the area of this and what is the area of this. Now, when you observe this symmetry, right, that symmetry drives you to conclude that this this triangle is exactly half of this, which means if I need the area of this triangle, which triangle? Triangle is described by three sides, right? So area of triangle, which is having sides as FE and FG, right, will be equal to exactly, since it's split into half, it will be half of x into y, right? Now, this is my first class in maths. I felt like going back to maths because mathematics is very powerful. Mathematics gives, the logical thinking to all subjects like physics, chemistry, maths, history also, right? This is my first class where I took just random. I don't want to, get into nitty-gritty of things like say this is the syllabus and this is what you have to cover. No, I'm going in a unbound thinking where I will talk about shapes, only shapes, and then give logical reasoning. And I'm not going to go into very complex calculations in this class first. And then I will slowly take you from this shapes to think slowly on step by step towards how do we go, arrive at calculus. And it's once you reach towards calculus, uh, you will use that, for various calculations, the real world calculation. And then, this is my first class. I'll stop it here. If you like this, give me likes. I'm going to talk more about geometry shapes. First, I'm going to talk about 2D shapes. Then I'm going to talk about 3D shapes. Then slowly, I'm going to talk about imagination of limits. So one very practical example of imagination of limits is your Earth, right? Earth is round in shape. But I can get something more better than that. Let's take this. Okay, circle with center. Okay, this is circle. Now, if I take a circle, okay, these are the points which I can join. Let's take a segment now here. So segment can join from here to here, right? I joined it. Now, if I make this circle bigger, Okay, let me take another circle, the bigger base. Okay, this is bigger, right? Now let's take 2 points here, point 1 and point 2. This is not radius. This is on the point. Now, when you take a pen and then say this is the earth, right? This is your earth. As these points M and L are far, they would appear like a circle. But as they start becoming near, right, they will start appearing as a straight line. So I would say that as the point L starts moving towards M, tends to look like a straight line. So what does this mean for a small child? He will simply not understand. He'll say, "What are you telling me?" But that's where we start thinking in terms of calculus. So I'm going to stop here. Stay tuned if you like this. I'm going to talk more on this in our next class. Goodbye. Have a good day. Enjoy mathematics.